Hey guys, it's Mrs. Moylan. This week in math class, you're going to focus on still working with those equations, but we're now going to include combining like terms. Combining like terms, okay? So here's an example of an expression. It's not an equation because it doesn't have an equal sign, but it's an expression. How many terms does this expression have? So I can count 1, 2, 3, 4, 5, 6. There are 6 terms in this expression. So sometimes you're just going to have to look and see how many terms there are. Sometimes you're going to have to actually combine those like terms. So you would want to look for things that are alike. Like right here, I have 5 y's and I have 1 negative y. So if I wanted to combine those like terms, 5 positive y's, 1 negative y would give me 4y. Okay? Now my y's are combined. Then I can combine my other like terms. So I have 2 positive x's and I have 3 positive x's, right? If I combine those, 2 positives and 3 positives, that gives me 5 positive x's. And then I can combine my constants. So I have 4 negatives and I have 8 positives. 4 negatives and 8 positives gives me 4 positives together. Right? And so I've just combined the like terms. There's nothing to solve, again, because it's not an equation. I just combine those like terms to simplify the expression. Okay, so that's one thing you might need to do. You also might need to combine like terms for an equation. So you would combine the like terms on the left, combine the like terms on the right, and then solve it like we've been solving. Okay, so if I'm looking at the steps for this process, step 1 is going to be to get rid of the parentheses using the distributive property. But since there's no parentheses here, I get to skip step 1. Step 2 then would be combine the like terms. So if we combine the like terms, right, I've got 5 negatives, and you can split your equation, 5 negatives on the left and 12 positives on the left. So I combine those terms to simplify. So negative 5 plus 12, or you can say plus 12 minus 5 equals 7, right? Now there's only one x term on the left side of the equation. So I don't combine that with anything. I just bring it down. And then the left side is taken care of. I'm still on step 2, combining like terms. Then I look at the right side and see what I can combine. So I see that I've got a negative 10 for my constant and a positive 53 for my constant. 10 negatives, 53 positives gives me 43 altogether. Then I want to combine my variables. I have 7 positive x's and 3 positive x's, right? So I combine those together and I have 10 positive x's. So this would be my equation, and then you would solve it like a regular equation like we've been doing. You might also get a problem that you do have to do step 1, where you have to get rid of the parentheses using the distributive property. So that would be your first step, right? So let's go ahead and do that step. Negative 4 times 2, negative 4 times 2 is negative 8n. Negative 4 times negative 1, negative 4 times negative 1 would be positive 4. And then I bring down that plus 7n. So the left side is taken care of with step 1. Now I need to do the right side. Right, 19, just bring it down. Then I'm going to distribute this 2. So 2 times n, positive 2 times n is positive 2n. Positive 2 times 6 is positive 12. Okay, so I've just completed step 1 of getting rid of the parentheses using distributive property. Step 2 then would be combine the like terms. Combine the like terms. So if I look at my constants, I only have a positive 4 as a constant on the left, and on my right, I see that I have constants that I can combine, right? So I've got 19, that's a positive 19 if there's no sign, and I'm combining that with a positive 12. So when I combine that, that's going to give me 31 for my constants, okay? So constants, constants. Then I can look at my variables. So I have 8 negative n's, and I have 7 positive n's. So when I combine that, negative 8 plus 7 equals negative 1n, or you could just say negative n, right? Left side is now taken care of. Right side, there's only one term with a variable in it, so that just gets brought down, okay? So this is my new equation that I'm going to solve. So step 1, get rid of the parentheses using distributive property. Step 2, combine those like terms. Step 3, move the variables and the constants by using inverse operations, which is what we've been doing, which feels like a million times, right? So I'm going to plus 1n plus 1n. That cancels out. Bring down the 4, bring down the 31, and 2n plus 1n is 3n, positive 3n, okay? Next step would be to move the constants. So I would do minus 31, that cancels. 4 minus 31 is negative 27, and then bring down. And then my last step, after I've done with that, step 4, divide by the coefficient. So the coefficient is 3, divide by 3, divide by 3. So negative 9 is equal to n, okay? So I've solved that. And then the last step would be check with substitution. Always check with substitution. So I wanted to show you something that might help with your checking with substitution. I borrowed my daughter's phone here. Okay, and I had her download this app right here. I don't know if you can see it. It says graphing. It's called GeoGebra. GeoGebra, right? And I was messing with it a little bit. Oh, Lord, how do I get rid of that? Okay. Okay, so if you download that, it looks a lot like the calculators that we used in class, and this is going to be real helpful for you for next week. So let me write that down so you know how to spell it. GeoGebra. And it's on the computer too, but sometimes it's nice to have it as the app, right? And so then for your substitution, you can just type in your original problem, but substituting your n with your answer of negative 9, and that might make it a little bit easier for you. So when you do that, both sides are equal to 13, and you know you got it right. All right, if you have any questions, don't hesitate to reach out.